All right.
Oh, is that you? Is it
We are on page 113 in your science book. We are doing reflection in mirrors today. It's going to be an exciting class. I'm just warning you right up front. This is groundbreaking material. Okay. In fact, it starts off talking about you laugh. You and a friend move towards the curved mirror. First, your reflection looks tall and skinny, and then they become short and wide. I know. At one point, your reflections disappear, even though you're standing right in front of the mirror. Imagine what it's like would be like if this happened every time you try to comb your hair in front of a mirror. I can't imagine. So I don't need a mirror. I don't even need a comb. So, all right. Reflection of light rays. And it is depending on how the light hits the mirror that causes certain reflections. Okay? The angles. Okay? We talked a little bit about the angles before. This goes into a little bit more detail on them. Okay? You do have something like 10 or 11 questions, 12 questions or something like that today that you will be answering. So again, most of it, all of it comes right out of your book. So just kind of pay attention so you know where to look. Okay? The reflection you see in a mirror depends on how the surface reflects the light. Okay? To show how light reflects, you can represent light waves as a straight line called rays. Okay? You may recall that light rays obey the law of reflection. I can't get it out. I'm blaming on lack of oxygen. Okay? So to show how light rays can represent light waves as a straight line, that is called a ray, R-A-Y-S. Okay? You also see that in math as you start to move up. Okay? Okay? You may recall that light rays obeys the law of reflection. The angle of reflection equals the angle of incident. Okay? That sounds weird, but what we're talking about is it depends on how that light hits it. It's always going to come off at the same angle. Okay? A regular reflection, and you're going to see that down here on the picture on page 114. When a parallel ray of light hits a smooth surface, okay, regular reflection occurs. All the light rays are reflected at the same angle because of the smooth surface, okay? You think about the mirror at your house that you look into to prep yourself and get ready, comb your hair, whatever, okay? The light hits it, it hits the mirror at a different place all the way down, but the angle that it reflects off of is always the same. Yeah. So it's a smooth surface because that's a smooth surface, you get a smooth reflection, okay? The other day when we had that CD in here and somebody was moving it around and you was getting rainbow colors and all kinds of stuff, that is because that is not a smooth surface. Okay? So although the light is hitting it at the same angle and it's reflecting at the angle, because it's hitting at different points, it is reflecting off at different points. So therefore, that is what is known as a diffused reflection. Okay? When a parallel ray of light hits a bumpy or uneven surface, that is when diffused reflection occurs. Okay? Think about a speed bump, if you would. Okay? If the light is coming in and it hits the side, it bounces off at the same angle. If it hits the top, it still bounces off at the same angle, but because it's hitting at different levels, it's not going to be if that was a mirror, it would not be a smooth reflection. Okay, it would be kind of distorted. Okay, it talks about water. You know, you guys have noticed this. If you're at a pond, even at the beach, if you're out on a boat and the water is really, really calm, you can see a little bit more clear reflection. But if you're out there and the waves are kind of choppy, not so much. You can't, okay, you don't see that because the light rays are hitting off of it at different angles, okay? A plane mirror, that's the one you used this morning to comb your hair and wash your face, brush your teeth, all that good stuff, okay? A plane mirror is a flat sheet of glass that has smooth silver color coating on one side, okay? Often the coating is on the back of the mirror to protect it from damage. When light strikes a mirror, the coating reflects the light, okay? Because, now that is actually behind, if you look at the back side of a mirror, most of the time it does have that coating on it, okay? Okay? Because the coating is smooth, a regular reflection occurs and a clear image forms. And that is, an image is a copy of the object formed by reflection or refraction rays of light, okay? And then you get into the virtual images, okay? The image that you see in a plane mirror is a virtual image. Okay, what does virtual mean? You guys that does the VR stuff, what do you virtual reality, virtual, what does it mean to nobody knows? Just play the game. What do you think?
Would it be like the reflection of something that you can't see? Like
No,
it's not there, but like it's there.
Well, yeah, kind of. Because you're looking in that mirror, that's not really you, but it's identical to you. Okay? It's just your reflection. Okay? That's not really you in the mirror. That's not another person that looks like you. It's just a reflection of you. Okay? So it's a virtual reflection of you. Okay? That's a virtual image. Okay? A plane mirror produces a virtual image that is upright and the same size as the object. That's why when you stand in front of your mirror in the bathroom as you're combing your hair, it doesn't look like a big giant standing there, or it doesn't look like this little bitty, toy soldier or something standing way back there that you gotta squint to see. It's the same size as you. It's you, okay? So how do images form, okay? Up there on figure 8 at the top of page 115, it shows how a plane mirror forms an image. Some light rays from the karate student strikes the mirror and reflects towards his eye. And even though the rays are reflected, the student's brain treats them as if they had come from behind the mirror. The dashed lines shows where the light ray appears to come from, okay? But actually, it's actually coming from the back. The dashed line shows where the light appears to come from. Because the light appears to come from behind the mirror, this is where the student's image appears to be located, okay? That's not something that you really have to know in life. It's just kind of interesting facts, okay? A concave mirror, okay? We talked about concave before, okay? I drew it up here on the board, okay? Concave, think about the opening to a cave, okay? You got the lens, and it's concave. It cuts inward, okay? So that's a concave mirror, or just a concave lens, or whatever, okay? But we're talking about mirror. A mirror is a surface that curves inward like a inside of a bowl. That's concave, okay? Show how a concave mirror can reflect parallel rays of light so that they meet at a point. If you notice over here in the picture on page 116, the ray of light are parallel to the optical axis. The optical axis is an imaginary line that divides a mirror in half, okay? Much like the equator divides the earth, okay? The point at which ray parallels to the optical axis and where they meet, that's the focal point. And that is important. Glasses, for example, has to have, they are actually convex, but they are designed to have the focal point that when it gets to my eye, it has to be in just the right place. Otherwise, they would not help my vision at all. I would still be sitting here going, okay, I can't see this. So the focal point has to be perfect for whatever stigma, astigmatism I have with my eyes is why I have to have them to read. Okay? Okay. Representing how images forms, ray diagrams are used to show where a focus image forms in a concave mirror. Okay? And you can see that over in that other picture there. Determining the type of image. A concave mirror can form either virtual images or real images. Okay? A real image forms when the ray actually meet. Okay? That's the real image. So real images are upside down, and a real image may be larger or smaller than the object. Okay? Think about this. We talked about it a little bit, and we're going to talk about it more, I think, Monday when we get into the eyeball. As you're sitting there looking at things, your eye actually picks it up upside down. Okay, everything you see is actually upside down.
So this is right side up?
No, but your eye sees it that way, but your brain, by the time it gets to your brain just that quick, your brain has turned it over to where it sees it. But the lens of your eye actually picks things up upside
Right
down.
side up.
Okay?
He literally just said no.
And then the optical nerve, no, we're not all in here standing on our heads. Okay? But our eye sees it that way. But by the time it gets to your brain, it's already turned it around just that quick. It is weird. It's really weird. Okay? When we get into it and we start talking about, you've got like 10,000 optical nerves that when you're born, well, not even born, but when you conceive, you got 10,000 optical nerves that starts coming out of where your eyeball is going to be and then coming out of your brain, and they all coming towards each other and forming, and they all got to line up perfectly. Those little bitty nerves, they all got to line up perfectly in order for us to see. And if you don't see that happening and think there's not a God, wow. I mean, that's, you want to talk about intelligent design. That's
Pretty
amazing.
crazy how
That
like
is amazing.
people are saying like people are ruining the world, people are mistakes, but like God made you so like detailed. Like you said that there's like stuff that makes a hair, just one strand of hair look like really big compared to these veins that are like behind our eyes. And there's like only there's like 10 million of these, and only one can match one other. They all match perfectly. So
They all match up, and they have to. They all have to match
that's
up.
also very, it's kind of crazy.
It is. It's amazing. It's quite amazing. You are very intelligently designed. You are an amazing.
Like, literally, it makes that verse sound
You are an amazing
fearfully-
piece of work. You really are. God, I mean, you can see the power of God in you. And all you gotta do, I mean, the human body is just a primary example of just the amazing how God can make, I mean, the smallest details that he put into us is just stinking amazing. And then you think about a fly or something of that nature, and I mean, he put the same amount of detail into that fly.
That you
I
just
mean,
swat.
it's just amazing. Okay?
Do you think God gets mad at us for when we like kill bugs or something?
No, God.
Okay. Now, convex mirrors, okay? A mirror with a surface that curves outward is called a convex, okay? This is a convex, a glass lens, something like that, contacts. You know, if you wear contacts, those are convex most of the time. So a mirror with a surface that curves outward is a convex mirror, okay? The ray spreads out but appears to come from a focal point behind the mirror. The focal point of a convex mirror is the point from which the ray appears to come. Because the ray never meets, images formed by convex mirrors are always vertical and smaller than the object, okay? I think I've got some lenses over here. That's one of the things we're going to do on Thursday. We're going to pull out some things and take a look at it. Same thing with a magnifying glass. I mean, it's the shape that causes the magnification. Okay. So convex mirrors are used in cars as passenger side mirrors. Okay? The advantage of a convex mirror, it allows you to see larger areas than you can with just a plain mirror. The disadvantage is the image is reduced in size, so it appears farther away. You ever notice that on a mirror, on a side mirror on the car? It says, it will tell you objects may be closer than they appear. Yeah. So, because the way they're curved, that car that is coming up beside you in this lane over here looks like he's really far back, but the truth is, because of the shape of the mirror, he's actually closer than you think he is. That's why you always have to kind of glance over your shoulder before you warp it over in front of someone. Or at least you should. There, we've learned how to drive. We've learned a little bit about mirrors. The class was actually pretty good today. I know, I'm shocked too. I'm just kidding. They're always wonderful students.
Said no, whatever.
Said, I didn't say that. That was from the horse's mouth. All right, bye.